Hello and welcome. In this video, we attempt to provide you a jargon-free introduction to data analytics. It's quite a buzz these days, and this video is meant for people who are yet to take their first step towards data analytics. So let's get started. What you see written here on the slide are some of the common terms that are being used very frequently these days, especially if you are a part of the corporate world and if you are looking for, say, different job portals and all, you would know that these are the terms which are commonly used and more frequently used these days. Business analytics, business intelligence, data analytics, and data science. It's not important for us to get into a debate as to how these vary, but for a starter, there is a good overlap between all of these. So there is a starting point, and when you develop your career in a particular direction, you can become more specific about what you want to pursue. But just for a quick introduction sake, let me tell you, business analytics is the use of analytics focused to business. That's for decision making, primarily for managers or stakeholders in the business. Data analytics is an overarching term which you can say supersedes the scenario of business and goes into the field of healthcare, could go into customer research, could go into education. So data analytics is an overall term. Business analytics can be a subset of it. Business intelligence would be a mix of analytics and a lot of analysis, which might come from your understanding of the processes and the way your processes flow. So this is more to do with analytics plus your subject matter expertise. And data science is I would say, the vastest term among all these, and it's very popular these days. This is a mix of multiple skills, and we'll talk about that as we move on later. Parallel to these terms, there is another term which is quite popular and is being used very frequently by people. It is big data. So what is a big data? So let me put it in simple terms. Any data that's beyond your system's capacity to process could be a big data for your system. When we talk about big data, there are certain V's which are important. V as in velocity, so it is getting generated at a very high speed. V as in volume, so there is a large volume of data that's getting stored. There is variety of data, so it's getting generated through multiple sources. The data may not be in a given specific file format or structure all the time. It could be from n number of resources, and there is something to do with the veracity, or you can refer to the accuracy of the data that's being captured. So big data is more technical, I would say, and technical owing to the aspects associated with its storage and the processing speed. So the techniques, the underlying techniques to work on the big data and approach from the analytics side of it would be the same. But yes, there are certain technical elements get associated. What's the buzz and what is it that people are talking about? So for example, Gartner says that in 2018, data and analytics can't be ignored. Analytics will drive major innovation and disrupt established business models in the coming years. Technical professionals need to adapt their data and analytics architecture from end to end to meet the demand of analytics everywhere. And McKinsey says there will be a shortage of talent necessary for organizations to take advantage of big data. By 2018, the United States alone could face a shortage of 140,000 to 190,000 people with deep analytic skills, as well as 1.5 million managers and analysts with the know-how to use the analysis of big data to make effective decisions. Now, these are some reputed names in the field of consulting and research, and if they feel that there is going to be a change in the way the businesses have been operating so far, of course, the businesses will need to hire for the right skill set. And that's where a shortage of the right manpower in the industry is anticipated. In fact, if you talk about Harvard Business Review, it is clearly called out that sexiest job of the 21st century is data analytics. So you can imagine that this is going to be there. This is going to be the demand and the future. Therefore, those of us who have not yet taken their first step in this direction should definitely consider doing that now. Now let's try to understand why the entire scenario has changed so much. One is that yes, we know there is a demand that has come up, but what has led to that demand? Of course, you all know that there is a good increase or explosion in the digital footprint. There is more and more social media that has come up. Every other person has access to a smartphone, the digital devices, tablets, and computers, and all of this in the arena of social media is somewhere or the other getting recorded, and some people refer to it as a digital trace. So our access to internet, the Internet of Things, and social media, all of these put together have led to a complete explosion in the availability of data. And to put it in precise numbers, this is how the stats look like. So 0.79 zettabytes of data was generated till about 2009. Between 2009 to 2011, you can say there is 1.2 zettabytes of data that's been generated, and it continues to increase. In fact, it's anticipated that by the year 2020, we'll have 35 zettabytes of data. And those of you who are not familiar with zettabytes, just assume that it's a lot and a lot of data. But you can look at almost an explosion here, several hundred times compared to what it was there earlier. And no wonder why the availability of data that's being generated would definitely encourage the businesses and the enterprises to understand and extract the value out of the data. But where we might be lacking is the fact that our education system didn't get modified. In most of the countries, the education system did not change as per the enormous amount of data that's going to be available. So people continued to study what they were traditionally studying for years. And at the same point in time, the businesses where the management was slow to react to the huge availability of data, they did not do sufficient investments in their employees to equip them with the right skills and prepare them for the upcoming demand. Having said that, some of you watching this video might be students. Now, there's nothing that you've lost. You can still go ahead and build a skill set in the field of data science, and there's a long way to go. There would be people watching this video who are already working and maybe they have decent years of work experience. Irrespective of that, you can definitely find a place for yourself in the data analytics arena. And we'll talk about it in the following slides. So no matter where you are in your career, if you're a working professional, the point is that you can always take that first step and gain something out of it, provided you are willing to take that first step. Now, if you say that you're in the mid of your career and you want to survive for next 20 years without acquiring these skills, the times could be really challenging for you, is all that I can say right now. So far, we have only talked about how the business scenario has changed and where the challenges could be anticipated if the businesses do not adapt to the understanding of data. But what is it that's in store for people who are working, or the individuals? So IBM predicts the demand for data scientists will soar 28% by 2020. And that's a huge demand by all standards. Now let's have a look at kind of salaries that different jobs in the field of data analytics are offered. So of course, there is a category of data scientists and advanced analytics, the one that you see kind of framed in green here. What is a data scientist? I'd just like to touch upon that. So data scientist is basically an amalgamation of three skills. Number one, a coder, a person who can write codes, knows programming languages, and has a comfort with these. Second would be the statisticians, or the people with skills in the area of mathematics. And third would be the business acumen. So data scientist is not just one skill, it's an amalgamation of three skills: the coders, the mathematicians, and the business people. So you see that a data scientist is a balance between these three skills. Now, it is quite possible that some of us do not have a background into coding. Can we still make a career into data analytics? Yes, very well. If you are really high on your business acumen and you know what you want in mathematical terms, you can still go ahead and ask your coders to work for you and they will take care of it. So it is not necessary that you need to balance all three. You can start from where you are. Just leverage on your strengths that you have. Moving on, as per a report published by PricewaterhouseCoopers, companies will look mostly for business people with analytics skills and not just analysts. What does it mean? Well, again, it points out towards the fact that no matter how good you are with your data, but there are certain practical aspects related to a business that you need to understand in order to be able to leverage the information that your data is giving you. So again, re-emphasizing, wherever you are in your career, if you've made certain progresses in the direction of business, you can very well adapt the edge through analytics and take your business goals forward. You can see there are multiple categories of jobs. So there are data-driven decision makers. Of course, they are highly paid compared to the data analyst. And there are analytics managers. If you see the last row here, these people will always have an edge compared to a plain vanilla data analyst. Let's look at the future. So once you enter the data analytics field, how does the salary progress? You can see the enormous amount of increase as the experience in the field grows. And by all standards, if you study how the salaries are distributed across different industries and sectors, by all standards, this is a very comfortable paycheck that we're talking about here. And then this is pretty much applicable to the global scenario. So irrespective of which country you are in, sooner or later, this is going to catch up. So let's understand what is analytics. And like I assured you, I will try to keep everything jargon free. So first of all, the word analytics came into existence from Greece. They had a word called analytikos, which meant involving analysis. What is the difference between analysis and analytics? It's very simple. Analytics always has an element of data associated with it, and analysis has more to do with the procedures and adherence to the procedures in very simple terms. Definitions of analytics. So there are two definitions that I like, and we've mentioned the names of the persons who have quoted these definitions. The analysis of data, typically large sets of data, by the use of mathematics, statistics, and computer software. It's important to note here that most of the work that you'll be doing in the field of analytics would be supported by some or the other computer software, a programming language, or a tool. It is almost impossible to work on those large sets of data and do all the calculations manually. The other definition of data analytics, which is more application oriented, is that analytics is the science of using data to build models that lead to better decisions that in turn add value to individuals, companies, and institutions. So this is a more practical definition, and if you just pay attention towards the words mentioned in bold, this kind of sums up everything that you need to know and what an analyst does. Let's get into different types of analytics. So there are three types of analytics. First one is descriptive. This describes what has already occurred. It helps the business understand how things are going. So this is a past data and you're just preparing a summary of that data and trying to understand. This is more reactive in nature and it has mostly to do with the past. Predictive, which is the most popular when we talk about of all types of analytics, tells us what will probably happen in the future as a result of something that has already happened. So now you're leveraging on the information that's available to you from the past data and trying to make decisions for the future. They help the business forecast future behavior and results. It is proactive. So basis what has happened, we want to take certain proactive measures for what's going to happen in future. And the last one, which is closely related to predictive, is prescriptive analytics. It helps the business prescribe right course of action. They not only tell us what probably will happen, but also what should be done if it happens. And it is again a proactive measure. So predictive tells us what's going to happen. Prescriptive is our action that we should take when we know something is going to materialize. So these are three simple forms of analytics. Talking about the languages and the tools, initially the tools to perform advanced analytics were only available via licensing, and the companies used to bear a hefty cost for these. The access was always limited to employees of some large size corporations, but now there are ample open source solutions supported by large communities across the globe that are constantly working on these open source solutions, and these come quite handy for all data enthusiasts. Two most popular languages are R and Python. Both offer integrated suites of software facilities for data manipulation, calculation, and graphical display. Now, you'd see there's a lot of debate available on these when you go online, which one is better, whether we should use R or we should use Python. the simple response without wasting any time on that debate is that both are good, choose one and move on. We'll now be looking at some of the use cases of analytics, and let me tell you, even if you're not directly involved in the business of doing analytics yourself, you can be assured that your buying behavior, your data, your presence on social media and through a lot of other channels is definitely being analyzed by the people who you do your business with. Nobody at this point in time in the digital age is untouched when it comes to analytics. Our use cases will only emphasize that further. 80% of the data that's available today is not in a structured format. That is, the data does not naturally come into text and columns. It could be a free expression written on internet, like a Facebook post. Text analytics is used to analyze customer sentiments. Let's say we are in the business of providing technical support to the customers, and we provide the technical support through a chat-based medium where the customers type their concerns and we immediately on a real-time basis try to cater to their requirements. Now, if say a customer is repeatedly using these words, repair, not working, slow, and there could be another set of words, trouble, frustrating, waste, refund, return, escalation. Now, if you see that most of these words have a negative connotation, I mean, there could be exceptions here and there, but overall, a customer who's initiating a chat and talking about repairs, of course, he's facing some or the other problem. And so is the case with similar words. Now, looking at this, you can very well imagine the sentiment of a customer. So in this case, you can very well imagine what would be the sentiment of the customer on the other end. He would be a customer who is almost given up on you. If, say, for example, he's a new customer and he has to face all of this, you can very well imagine that even if he survives with your product, he is not going to talk positively about you. That's guaranteed, right? So what can we do to prevent these things from happening, and can we take charge of the situation immediately and do a course correction? HR analytics. Now, employee attrition, if you know, is a big problem for the companies. And they spend roughly about 20% of the CDC, the cost to company of a churned resource, to find his or her backfill. And not only that, this is just to get the backfill. When a backfill takes up that position, he needs a learning curve to be able to come to the same level of performance. So it's about money that you spend and the patience that you have to bear with the new employee till the time he catches up. Data scientists have developed algorithms powered by key indicators that, taken together, can dramatically predict an employee's intent to stay with or leave the company. So let's say there are about 25 to 30 attributes that are critical when it comes to predicting employees' attrition. And if a company constantly keeps an eye on those, it would be able to address the employees' issues in a more proactive way, rather than waiting for the day when an employee comes and submits his resignation and then you try to do an exit interview and then try to retain that employee. That's almost too late. He's already made up his mind to move out. Another case could be a customer lifetime value, and I often ask this while teaching people, why do you think the companies provide you a loyalty card? And a lot of responses come, a mixed set of responses. People will say that they want to make me feel good. I earn some loyalty points and I invest those points there so they get more business out of me. Of course, it's in a way to pay you respect that you are a valued customer, but the real motto is to be able to track what you're doing. See, it's easy in terms of an online transaction to figure out that you logged in and you used a particular user ID and password to make a purchase, say on an online portal. So they know who's purchasing what and they keep a track of it. But in a brick and mortar store where people just walk in and pick a number of products that they want to buy, say it's a supermarket, how would you track what's my lifetime value if you do not have a loyalty card? So if I have a particular number associated with the final billing that I do at the counter, you know that I walked in after 2 months and these are the items that I purchased. This could be a good way to track the outcomes of different promotional campaigns that the supermarkets run from time to time. So say, for example, if I gave a very good offer, a huge discount on a consumable that is in regular use of my customers, I will be able to see if they have been able to take advantage of it. This is a very interesting case, and let's understand that while these are specific examples, they can be generalized across industries and scenarios. Here we're talking about India, and we're talking about a problem of tiger. What happens is there are a lot of groups that are into this business of tiger poaching, and they assume that there's some superstitions or beliefs that exist that tigers' bones can be used for making certain medicines which are a solution to certain incurable diseases. Now, this has been happening for years, and these people who are poachers are pretty smart, so they know the jungles really well, at times better than the forest officers themselves, and that's why there is a chase between the two all the time. So, over the past few years, computer codes were written, and about 25,000 data points have been analyzed since 1972 across 605 districts on wildlife poaching crimes. Using this data and applying appropriate techniques, the wildlife savers could narrow down on certain hotspots where the tiger crime was more likely to happen, and this helped them prevent and control tiger poaching. Now, talking about healthcare analytics, and this is a very, very important and well-known study called Framingham Heart Study. It was performed in the United States. It's the name of a town where the people participated in the study. It originated in 1948 when the scientists and participants embarked on an ambitious project to identify risk factors for heart disease. Today, the study remains a world-class epicenter for cutting-edge heart, brain, bone, and sleep research. What it enables you to do is that when you go to the site, you'll be able to see that putting your characteristics, you can very well figure out what is your risk score to acquire a cardiovascular disease, say in a time frame of 10 years. So you can generate a Framingham risk score that tells you that you are prone to have a heart disease given the kind of habits that you have right now. And it's an interesting area. So you can see that it's not just in terms of business applications that we talk about analytics. It is not just about targeting the right customer for a promotion. It goes on to prevent crimes. It goes on to save your life, ensure that you live a longer and healthier life. It can be applied to almost all the industries and sectors. That's why it's fair to say that the world around us is changing, and we need to equip ourselves with the right set of skills. It's a short video we tried to put together to ensure that you get a sneak peek into what is analytics. If you like this video, please don't forget to subscribe to our channel. That encourages us to continue making more such videos, and do recommend us to your friends who might find it valuable. Thank you for your time.